Hi everyone, I am Avinash Misra, roll number MN0565. Today I am going to give a brief knowledge about hydraulic support system in longwall mining. These are the following topics I am going to discuss: introduction of support system, development of power support system, parts of power support system, types of power support system, advantages and disadvantages of support systems, important dimension related to supporting. Let's move to introductory part. Longwall mining method is the most popular method of coal deposit mining. Many miners work together to take the coal seam at the same time. They build stone walls and use timber posts or props to hold up the roof as supports. Presently, steel longwall supports are used and the mechanized or power supports will be discussed in this presentation. The geological characteristics of coal should be critically considered before any design can take place. This will determine the nature of the design. Example of such characteristics are seam thickness, condition of the roof and floor, hydrogeological condition of deposit, volatile content, and so on. Development of power systems. Metallic support are used mainly in longwall mines in form of section or units attached to each other. Depend on the length of the longwall face. Some longwall faces can be as long as 150 to 220 meter. The friction and hydraulic pumps with articulated caps were early steel supports used. The articulation of caps permit placement of the prop toward the end of the working shift, thus creating an area of prop free face for the chain conveyor to move freely and for the coal winding machine to cut and transfer the coal to the conveyor. The props are telescopic, made of two pieces sliding one inside the other and set according to the thickness of the seam. Hydraulic props were further improved by making the hydraulic prop, cap and chain conveyor movement in a single unit called walking support or power chokes. In the following diagram, there is A and B show side view and C show a plan of support system. Parts of power supports: canopies, bases, legs or jacks, control system. Let's move to canopies. The canopy size ranges from 1.61 to 9.4 meter. Maximum roof pressure at yield about 4.2 to 33.2 kg per centimeter. Solid roof canopies have been found to maintain an average 41% contact area with the roof. Contact area increases to an average of 68% when articulated canopy is used. Bases. Generally, bases for frame supports are built into two halves, where solid bases were used for choke and shield supports. A solid base provides better stability. Each base is provided with skids. The most popular design is a combination of a rear skid and a single split forward skid. Guide bars are used to transfer the arm jack force to guide the support units during advance without undue side loads. The optimum size of the base for a specific seam floor is such that its unit loading pressure at yield is less than the bearing capacity of the floor rocks. Legs or jacks. The bore diameter of the hydraulic legs of power support ranges from 10 to 30 cm with operating pressure of the hydraulic pump. When the legs are raised against the roof, the total load exerted on the roof is defined as below. P is equal to Pi into A into N, where P is equal to total setting load in kilograms and Pi is equal to operating hydraulic pressure in kilogram per square centimeter. A is equal to cross sectional area in square centimeters. N is equal to number of legs. Therefore, when the roof starts to cave, the hydraulic legs are forced to retreat and hydraulic pressure in the legs increases. The pressure at which the yield valve will open is called the yield pressure. The corresponding load applied on the roof is called the yield load. Most support capacities are designed to incorporate the yield loads. Control system. Supports can be controlled in various ways, such as individual support manually from neighboring unit, manually from selected points at the face, automatic point control from the gateway. Types of power supports. There are four major types of power supports which are designed for various conditions, such as choke, frame, shield, choke shield. Let's discuss about choke power supports. The choke type of power support is the earliest used. It is hydraulic in nature. The old type of choke power support is composed of a block or a choke of one horizontal and four vertical pistons. The vertical piston supports the roof and the horizontal piston pushes the conveyor. Currently, there are choke powered supports having 6 legs. The back of the choke is protected from the caving blocks and the rigid canopy has elongation to cover the roof after the cutting machine has passed. In the figure, there we have shown full width rigid canopy, leg, self-centering leg housing, double acting arm, front base structures, walkway floor cover, and a rear base structure. Frame power supports. The frame type is composed of two different support of 2 and 3 leg units. The 2 leg unit is connected to the conveyor and advances with the cutting machine to cover the freshly opened area of the roof. 3 leg pieces are used to support the back of the face after the cutting machine has passed. They advance and align again with the 2 leg units. Modern frame power support now has canopy which is articulated and has prolongation to cover the face area right after the cut. In the figure I have shown canopy, gov shield, base, hydraulic arm, spill plate. Shield power support. Shield support were developed in order to keep up with easily caving faces. The shield support consists of an inclined plane whose lower end is hinged to a horizontal base plate that sits on the floor, while the upper end is hinged to a horizontal roof canopy in contact with the roof. Due to various development made on shield support, we have three types of shield support. One is caliper shield, another is lamiset shield, and another is four-leg support shield. In the figure, I have shown canopy, gov shield, base, hydraulic arm, spill plate, leg, and control. Power system. Advantages and disadvantages of power system. Lower convergence. Hydraulic system control the roof very efficiently. Large canopies hold the roof effectively. High production. Owing to mechanization, the system are able to advance as much as 5 to 6 meter a day. The increase the production more than 1500 to 2000 tons, decreases the number of faces required, and obtains the concentration in the mine working. And safe production. Effective roof control has minimized accident caused by roof falls. High efficiency. The output per conventional man shift has increased tremendously compared to the output of conventional support system. And following these are the disadvantages of power system, such as capital cost. Power support require high capital expenditure. Unless there are large panels available, they may not be justified. High cost of upkeep. The cost for upkeep is much higher than the cost for conventional supports. Quality labor. Power support system do require highly qualified labor. Geological specification. Geological specification are difficult to meet. Large panel, small fluctuations in seam thickness, and condition of mechanical workability should be met. Design of a power support. The design of the power support depends majorly on the geological and stress condition of the coal strata. For example, if low yield capacity supports are used in a strong roof, hardly caved, the pressure will not be met by the supports. The roof will not cave as the face advances, and the excessive pressure will result in heavy upkeep expenses on supports. Conversely, if a high yield support is used in a weak roof, there will be intrusions to the roof, and the unnecessary use of high cost power support increases the expense. Thus, the correct capacity of power support should be chosen to meet the condition. Important dimension related to supporting systems. Yield pressure. This is given by the formula Py is equal to 1.25 into Pi, where Py defined as the yielding pressure kg per centimeter square. Pi is operating or setting pressure in kg per centimeter square. Distance between supports. This depends on the roof and floor condition, bearing capacity of the support, gov condition, or the rate of advance. It is usually taken as 1.2 meter from the center to center. Unsupported face distance. This is the small distance between the coal at the face and the end of the canopy. This distance increases as the winding machine cuts. Load density. Load density is given by the formula N is equal to F by Ls plus L naught into C, where N is equal to load density in tons per square meter, F is equal to carrying capacity in tons, Ls is equal to length of the canopy in meters, L naught is equal to length of unsupported face in meters, C is equal to distance between supports in meters. These are the recommendations I would like to give. It must be ensured that before any design or construction is carried out, the geological characteristic of the deposit must be put into consideration. Future exploration on mineral deposits should provide sufficient and reliable details or data and not just assumptions. Research work on mineral deposits and their exploitation should be highly encouraged. Longwall method of mining should be applied in mining coal deposits since it ensures safety of workers and high productivity. The roofs of longwall faces should be well supported with well designed power supports. Conclusion: the design calculation are carried out in order to determine pressure loads exerted by the overburden above the power support at the face. These pressure loads therefore determine the dimension to be used for the designs. Longwall method of mining should be adopted with a properly designed power support system for the longwall face, making it safe for mine worker and machineries to work efficiently. Also, longwall will yield higher production and profit at a minimum cost. Thank you, sir.